Hello students, how are you? Today we will study the geometrical part, that is properties of angles formed by parallel lines and their transversal. Okay? So properties of angles formed by parallel lines and their transversal. So this is transversal or transversal line. Transversal line. And before going to this, just I want to make you remember what parallel lines are. Okay? So you see, I can represent a line like this. Let it be a step path. And both arrows are here. It is a line, but we cannot draw a line. All of you know. You see, we cannot draw a line because it is extended in both the directions. It is still moving in both the directions. So we cannot draw, but we can represent a line. So so this is a line, and we can name this. Either you suppose L1. Either you use the small letter like A, B, C, like this, or you may represent, suppose mark 2 points. So I may represent like this, or I may represent like this. Suppose small letter, I may also represent like this. So here I represent one line. Okay? Suppose I represented this line, let it be L2. So these are two parallel lines. What does it mean? Two lines will be parallel when provided they lie in the same plane. Next point, they do not intersect each other. They do not intersect each other because these are extended in both the directions. It is not straight, just you feel like that. That means the distance between the two parallel lines never changes, that is constant. If you draw a right angle here with the help of the protractor, you see, suppose this is 90 degree. And if you draw here this angle 90 degree, you see the distance is always constant. The distance is always constant. That means the distance between the two lines never changes. Neither it increases nor it decreases. It is constant. So two lines are said to be parallel when now they will have to lie in the same plane and they do not intersect each other. So these are about the parallel lines. And you see, what is the transversal? What does it mean? What is the literal meaning? You see, suppose I represent two non-parallel lines. You see, the distance increases or not? Suppose you see the distance increases. So the distance between the lines, two lines, is not constant. So these are two non-parallel lines. Let it be L3 and L4. These are non-parallel lines. Non-parallel lines. So we'll discuss now about transversal line or transversal. What does it mean? You see, suppose I represented two non-parallel lines, and if it is caught by a line, let it be L1, L2 and it is L3. So two non-parallel lines L1 and L2 are cut, cut by a line that is L3, this one. So this is called transversal or transversal line. So here L3 is called transversal line, transversal line, or in short you may write transversal. So what is transversal or what is transversal line? A line that passes through two lines in the same plane at distinct points. Distinct means different points. You see, here it is one point of intersection. Let it be A. Here is the another point of intersection B. So a point A and point B are distinct points. And you see, L3 line that passes into two lines L1 and L2, same plane, because in the same plane two non-parallel lines remain, and the line L3 that passes through two lines in the same plane at different or at distinct distinct points at A and point at B. So such type of line is called transversal line or transversal. So first you should get such idea. So you should be fundamentally clear before making your entry into properties of angles formed by parallel lines and their transversal or transversal line. Okay? So I erase it. Suppose I represent here two parallel lines and towards right two non-parallel lines, and in both cases I will use the transversal. You see, L1 is parallel to L2. Two parallel lines, the lines will be parallel when they remain in the same plane and they do not intersect each other. Already you know it, we have discussed. So these are two parallel lines. So this is transversal, let it be L3. And here suppose L4, L5 and this is L6. So you see, when we are doing this, what we are doing? Now here in the figure A and in the figure B. First of all, I will discuss about the figure A. You see, two parallel lines L1 and L2 are cut, CUT, by the transversal L3. Here L4 and L5 are two non-parallel lines and these are cut by the transversal L6. Okay, let's move. Properties of angles. What types of angles are formed here? We have to mark first. In both the cases, first you see interior angles. Interior angles. And you see in the figure A, which are the interior angles? You see, if I name them, you see, suppose this is angle 1, this is angle 2, this is angle 3, and this is angle 4, and this is angle 5, this is 6, suppose this is 7, and this is angle 8. So interior angles, which are interior angles? You see, in between the two parallel lines, here this one, this one, this one and this one. In between two non-parallel lines in figure B. But in figure A, between two parallel lines L1 and L2, which angles are there? Angle 1, angle 2, angle 3 and angle 4. These are interior angles. Okay, so we can write here angle 1 or angle 2, angle 3 and angle 4. Number 2, exterior angles, that means towards outside. Exterior angles. You see, angle 5, angle 6, angle 7 and angle 8. These are not in between two parallel lines. That means this angle, this angle, this angle and this angle. These are exterior angles. So in figure A, I mentioned here, you see, angle 5, angle 6, angle 7 and angle 8. These are the exterior angles. Next, what types of angles are formed? Alternate angles. Alternate angles. You see, angle 1 and angle 3. These are in pairs. You see, interior angles. These are individual angles. These are individual angles. But alternate angles, we will have to write in pair. So one pair, the number is 2. So in one pair, that means there are two angles which will be called as alternate angles. You see, 1 and 3. It is one pair. Then you see 2 and 4 or 4 and 2. Two and 4. Then you come 5 and 8. Six and 7. These are the alternate angles. In this case also, you see, this angle and this angle. This is one pair of alternate angles. This angle and this angle, second pair of alternate angles. This angle, I give a tick mark, and this angle, that is the third pair. And I give a cross mark here, this angle and this angle. This is the fourth pair of alternate angles. These are the cases. But what happens, you see, let us complete that. The number 4. Corresponding angles. We will discuss it, the alternate angles and corresponding angles vividly. Corresponding angles. Angle 5 and angle 2. These are also in pairs. Angle 5 and angle 2. Angle 5 and angle 2. That means this angle and this angle. These are one pair of corresponding angles. Then angle 1 and angle 7. Angle 1 and angle 7. Come to this side. This is the transversal. It has both the sides. This is one side, this is the other side, opposite side. In one side we got two pairs. In other side we will get two pairs. Angle 6 and angle 3, angle 4 and angle 8. Angle 6 and angle 3, angle 4 and angle 8. So these are the pairs of corresponding angles. And here you see, suppose I am write A, B, C, D, E, F, G, H. So you see, if I write the corresponding angles, you see, here it is A, B, C, D, yes, angle D and angle H. Angle A and angle E. Angle C, angle G. Angle B and angle F. 4 pairs of corresponding angles. And you see, in alternate angles, just we will go. We'll discuss about these two. I just erase it. If two parallel lines are cut by a transversal, then the following properties are true. What are these, you see? Alternate angles are equal in measure. If two parallel lines, so this case is discarded, we cannot take, because here two non-parallel lines are cut by the transversal. Alternate angles exist, corresponding angles exist, but here in this case alternate angles are not same in their measure. So two parallel lines should be cut by a transversal, then it is true that the alternate angles are equal in measure. Here the alternate angles are not equal in measure. So reason is why? Why? Because here two non-parallel lines are cut by the transversal. But here these two lines L1 and L2 are two parallel lines. So in case of parallel lines, when they are cut by a transversal, the alternate angles we find these will be equal in measure. That means you see angle 1, measure of angle 1 is equal to measure of angle 3. This is one pair. In each pair of alternate angles, both the two alternate angles are equal in measure. So you see, it is very much interesting. You have already known it is Z or not. It is an English alphabet. You see this angle and this angle. If these two lines are parallel and this is also transversal, you just extend it. It will be easier for you to know. Use. So this angle and this angle. This is one pair. So one pair of alternate angles as a transfer. This line of Z, letter Z, this is the transversal. So two parallel lines are cut by a transversal. So we have a pair of alternate angles. So they will be equal in measure. Suppose this is 1 and this is 3, like this. So next you see angle 4, angle 2, or angle 2, angle 4. From which angle you may start? Suppose angle 2. The measure of angle 2 is equal to measure of angle 4. Then you come to, you will go to exterior side. You see angle 5 and angle 8. This is one pair of alternate angles. So angle 5 measures equally with angle 8 and angle 6 with angle 7. So there are 4 pairs of alternate angles also in this case, but here there are 2 non-parallel lines which are cut by the transversal, but here 2 parallel lines are cut by the transversal. So this is going to be true. What? Now in one pair of alternate angles, both angles are equal in measure. So you see angle 1, angle 3, one pair, angle 2, angle 4, second pair, but these are in the interior side. So these two, no doubt, alternate angles, but will be better alternate interior angles. These angles are between 2 parallel lines. You see, both 1, 2, 3, 4. These are interior angles. These lie in between 2 parallel lines. Okay? Then you come to these 2 angles. Angle 5, angle 8, angle 6, angle 7. They exist, but in the outside. So there are also alternate angles. There are also 2 pairs of alternate angles. But if you write, you may write like this: alternate exterior angles. They are alternate angles, but they are alternate. It is more precise if you write alternate exterior angles. And you see in each pair, both the angles equal, measure equally. or they are the equal measure. So this is about the alternate angles. Here the alternate angles exist, but in each pair the alternate angles are not equal in measure. So let's move to the corresponding angles. I erase this. Property number 2. Corresponding angles are equal in measure. So I erase this because we are not discussing about the two non-parallel lines. This is L1. This is the representation of the second line. This is L2. This is the transversal L3. So let us start from here. 1. This is angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. So corresponding angles are equal in measure. So corresponding angles, you see how to identify the corresponding angles. You see, this is the transversal. You first select one side, either this side or this side. Anyhow, first we will have to decide to take one side. Suppose we will take left side, this side. You see, angle 1 and angle 5. You see, this is one pair and these are equal in measure. Then angle 4 and angle 8. Then come to the opposite side. This side is over. We will go to this side of the transversal L3. So you see angle 2 and angle 6. They have the equal measure. Angle 3 and angle 7. So in each pair, you see the two corresponding angles are equal in measure. Because already I have told you, two parallel lines are cut by the transversal. So the corresponding angles are equal in measure. So you will have to remember the property 2. Then we will go to property 3. What is property 3? You see, the interior angles on the same side of the transversal, on the same side of the transversal are supplementary. When two angles will be supplementary? If the sum of the measure of two angles is equal to 180 degree. So these two angles, if their sum of their measure is 180 degree, then we will tell that they are the supplementary angles, or both the angles are supplementary to each other. And you see, This is the transversal. What it has been written, just you follow. The interior angles. Okay. I have, this is also interior angles, this is also interior angles, this is also interior angles, this is also interior angles. There are 4 interior angles in between 2 parallel lines. But the condition is on the same side of the transversal. So we have 4 interior angles. This is the transversal. In this side there are 2 interior angles. In this side, in the opposite side, there are 2 interior angles. So on the same side, we have 2 interior angles. So if I write 1, angle 2, angle 3, and angle 4. So angle 1 and angle 2 and angle 2. These 2 angles are 2 interior angles which are on one side of the transversal. And the next one is angle 3 and angle 4. This is on the other side. That means on the same side, on this side we will find angle 1 and angle 2, and in this side, on the opposite side we will get angle 3 and angle 4. But on the same side, suppose angle 1 and angle 2, both the angles are supplementary to each other. That means the sum of the measures of the 2 interior angles is equal to 180 degrees. That means measure of angle 1 plus measure of angle 2, that is equal to 180 degree. Or angle 3 plus angle 4. Sum of the measures of angle 3 and measures of angle 4, measure of angle 4 is equal to 180 degree. That means both the angles, you see, are supplementary to each other. Sum of their measures is 180 degree. So there are 3 properties involved as the properties of angles. These are the properties of angles formed. How it is formed? When 2 parallel lines are cut by the transversal, and you will have to remember this. Okay? So in the next video we will discuss on the angle sum property of a triangle, and also we will discuss the exterior angle property of the triangle. Okay? So in the next video we will do that. So wish you all the best. Thank you.